We're looking at the first year core textbook, and we're on mixed exercise 6, which is on circles, and we're on question 7. I think this one is sort of the first slightly not unusual question, but maybe first quite tricky question. So it's an exam question, and it's worth 6 marks, and it's also problem solving. So that means that maybe the method isn't going to be immediately obvious. So we've got a straight line and a circle, and we're trying to show that they, it tells us that they do not cross. And then we've got to hopefully come up with this possible range of values for P. Okay, so it's almost worth sort of ignoring that to start with, because that I think could be quite off-putting. So what would you do if you were trying to find out where a circle and a straight line did cross? So that would be solving simultaneous equations. And pretty much every time, the best method is going to be to substitute this one into this one. Because obviously trying to rearrange this one to make X or Y the subject's going to be a bit of a nightmare. So this one, obviously, I would say it's easiest to just add the Y over. So I got Y as the subject, and then if I jot down the equation of circle as it appears in the question. Okay, so if I substitute, so for Y, I am going to substitute in 3x minus 9, so I'll end up with, well, I was going to say an equation just in X, but obviously it's got that P there as well. So we'll come on to that next. So that would give me X squared plus PX. And then where it says Y, I'm going to substitute in 3x minus 9. And again, there. And okay, so I've got I have got a quadratic in X. It's just got that unknown P in, but then that's sort of what we're getting to with our final answer. So let's tidy all that up. So I've got X squared plus PX. 3x minus 9 all squared, so just be really careful. Obviously that means 3x minus 9 times 3x minus 9. So that's going to give me 9x squared minus 54x plus 81. Then I'm looking at this term, or these brackets here, so that's going to be 12x minus 36. So let's make that all equal 0. So what have I going to collect the like terms? So they're my only x squared terms. So I've got 10x squared. For x, so well, I've got the minus 54x plus 12x, so minus 42x. But then I've also got the plus p. So they're my x terms all collected together. Okay, and then if I factorize that, so basically it's p and then also minus 42x. This is, hopefully, somebody might spot it, this is going to be a discriminant question. So by writing it like that, I've then got my value of b for the discriminant really clearly. Okay, and then lastly, the constants. So what have I got? So well, I've got 81, minus 20 is 61, minus 36, I'm going to say is 25. I'm going to double check that before I crack on with the question. In fact, it's been a long day, so I'm going to stick that straight to my calculator. Yep, I'm good. Okay. Okay, right. So now, so we've kind of got quite a long way through this question without really thinking about where we're heading with it. But if we're saying they don't intersect, basically what I'm saying is this should have no real roots. And if it has no real roots, that's where the discriminant is less than 0. So just thinking about this type of question, if it had said they just touch, that would be when the discriminant equals 0, because it would mean that it was repeated roots, which is one answer. And if it said that they do intersect, this would be greater than 0. So A is 10, B is P minus 42, and C is 25. So let's put those into the discriminant. So, right, okay. So B squared is going to be, let's change that back to black, right. So B squared is going to be P minus 42 all squared minus 4 times A times C, and that has to be less than 0 because I'm told that the two lines don't, the two curves don't cross. Okay, so let's square those brackets out. So that's going to be minus 84p and then plus 1764, and then minus 10,000. That seems quite big. Yes, because I typed an extra 0 in there, so it's minus 1,000. So p squared minus 84p plus 764 is less than 1,000. So that's the quadratic inequality. You are absolutely fine to put that into your calculator. In fact, I can see from these answers here that this quadratic does not factorize, because these are clearly coming out as surds. So yeah, I'm just going to go straight. So my calculator emulator is not working, but I'm going to go to option B on my menu, my inequality solve mode. I'm going to select option 2. I'm going to type in A is 1, B is minus 84, and C is 764. And I'm going to breathe a huge sigh of relief, because on my calculator screen, it's literally coming up with that exact answer there. It's just, obviously, my calculator's got an X instead of a P. Okay. Now, my only worry about this is because it was a show that question, I guess I have got maybe a little bit of an issue in that I've not really shown, well, haven't shown at all, how I've got to this final stage. I think I'm going to backtrack a bit and say that you would need to show a little bit of sort of logic as to how you got there. So if we go back to this, so you don't need an accurate sketch, but obviously this is a positive p squared or positive x squared, so that means we know it's a U shape. So in fact, I don't even need the y-axis there. All I really need to just show, just to justify my answer, is it's a U-shaped quadratic. I'm looking for when it's less than 0, so it's less than 0 anywhere below the x-axis. So that's why I'm getting, well, that's why my final answer is between the two roots. So that would be 42 plus 10 root 10, and that root there would be 42 minus 10 root 10. And because it's less than 0, that's why it's that part of the graph. So that's why it's between those two values. So let's just see how they justify it. No, yeah, well, there you go. They don't really. They just kind of go straight from that to that. So we must be fine with ours.